Hello, everyone, and thank you for joining us today. My name is Jacob Rausch, Head of Development at SQE, and what you see on the screen here right now is the SQE Sandbox launch page. This is where every session begins by entering your unique session code. Today, I'll be walking you through the SQE Sandbox, a live demonstration of the quantum secure foundation we've built to protect data, identities, and communication, and a bunch of other features, as Hamid has just previously mentioned. You'll see how each user is assigned a 1024-bit decentralized identifier known as an SQID, created instantly upon registration. From there, we'll dive into a passwordless login process and witness browser to backend entanglement through the use of our zero-knowledge keypad. Our encryption framework eliminates the need for traditional public key cryptography, delivering the same trustless security, but without the exposure. Once inside the dashboard, I'll show you two of our core use cases, secure messaging and simulated secure payments. Though we believe, as we've previously just talked about, this is just the beginning. This is the tip of the iceberg of what this technology really enables. So to learn more after today's demo, visit sqe.io or explore our YouTube channel, SQE_secure. For deeper dives into the SQE ecosystem, we have visuals, explainer videos that kind of go into each individual specific topic, like our SQIDs, our hardware devices, and whatnot. So let's get started by entering our session code. In this case, it's 1234. And once you type in your valid session code, you're going to be brought to the registration and login page. And so here you'll see a few different things. You're going to see information pop-ups on almost all of our pages that give kind of a summary of what I'm talking about today for future reference to go back to, as well as where you can learn more about specific topics. And so essentially, we have just a basic user form for registration. We have the username, we have your email, first and last name. That's all that's required for this sandbox. It's important to preface that this is just creating a temporary SQID, so it's not reliant on your real personal user data, but to create a level 2 registration, what we call that gives us enough information to be able to validate and verify you to create and receive secure payments. We show that the date of birth, social security number, other things that we can that are essentially permanent to you, that we can tie the SQID, the encrypted information based on your user profile, to identify you and uniquely tie it to your user profile. And so we also have a drop-down menu, as you'll see, with our banks, that you can choose any one of these 4 banks, and that essentially just simulates a bank account that you may have that allows you as a user to simulate bank transfers, sending and receiving payments. And so essentially, once you create that account, before the SQID is created, you're brought to our graphical keypad page. And this is really where the magic happens in allowing to secure your browser and initiate that entanglement that we just talked about between the browser and the SQE network. So right now, you're going to see a few different bitmaps emerge every 5 seconds. All you have to do is click 4 points at this time, and that would be enough to, using zero-knowledge principles, to create that initial entanglement, create that quantum secure session for the browser and the SQE network to send encrypted and be able to decrypt those packets without having to send a key in the process. And so what we can also talk about here is how this keypad is essentially can scale in complexity, right? So not only can it be used for initiating that entanglement, but it's also will be a tool for human validation using behavioral biometrics, so that you can go through and register through your SQE account without a password. So it's a passwordless login, as well as previously talked about, AI resistance, making sure that you as the user are who you say you are when you log in. And so we'll do a deeper dive into the login process here in a couple minutes. But what you'll see is essentially that keypad. You can click any 4 digits. It's not a pin. You can select any 4 numbers every time that you want to entangle yourself with the network, and boom, that's it. Now you're entangled. We just registered. We were given a 1024-bit SQID that was created through our network based on, again, that temporary user profile that we're creating in this sandbox environment. And what you're going to see is a few different things on this dashboard page. It's important to also understand that everything, now that we are entangled, now the browser and the backend are now in sync with each other. The keys are evolving fast as time goes on. And so every packet that is sent on and received between the front end and the back end are now going to be wrapped in our SQE quantum secure bit level encryption. And so to kind of describe a few things on this dashboard, you're going to see the SQID right next to the username at the top. We have our informational button here that kind of gives a rundown and a summary of kind of, again, what I'm talking about today and the different tabs that we have on our page. You can view the full SQID by hovering or clicking and being able to take a closer look at that. We're going to be having a lot of new releases and features to be able to get users to, test our ecosystem and the different features. So we have that report issue button as well to continue to improve this sandbox page. And so now here, what you see is our payment field. And this is to demonstrate to you one of our core use cases, secure payments. And so we really want to preface that this is just one of the many use cases that can be available. Right now, our secure payment is wrapped in ISO 222 compliance, but this encryption wrapper, the idea of this using the SQE encryption as a wrapper, can go around any existing architecture. It's not a rip and replace. It's a cohesive tool that can be added as a secondary layer to whatever encryption is already in your tech stack, as well as be also, because it doesn't rely or eliminates the need for public key cryptography, it can be a very strong secure primary control as well. And so as you just saw, we just sent a payment to virtual Alice. If there's no other users that are active, we always have 3 virtual users to be able to demonstrate these core use cases that I'm talking about today. You can see that it's in progress. Each milestone is happening live, and that we are tracking each milestone to, again, simulate the different points that are happening for a safe and secure delivery. We have our information button as well that goes over each of the different tabs and what's going on behind the scenes. We have our audit report here that shows the payload of every single milestone being hit, again, through the use of the ISO 222 compliance. We map each milestone to the controls based on that compliance. And again, this is a wrapper, so we can wrap this with any compliance, which we'll show later on with our compliance mapper. Here we have what really the thick of it here is, this is the encryption, right? So we want to be able to display that encryption for everyone and be able to see that bit level encryption that Hamid was just talking about. You can see that there's no correspondence, there's no patterns, it's fully random. And again, time is evolving. So the back end and the front end are perfectly in sync with each other to be able to encrypt and decrypt these packets. Right now, what you're seeing here is the initial payload. So the moment you send that payment, the initial payload, which you'll see here in a second, the decrypted version is being encrypted. That's what you see here. And then the backend receives that encrypted version. Because it's in sync, it's got that entanglement initiated by our zero knowledge keypad. We can then decrypt it on the other side, and it will receive a response that you saw. And so here, what I'm going to do now is log out. Where we see that the account balance updated, and we're going to describe a little bit about our login process now. So we retype our session code. And then in the login, you can see, as previously mentioned, this is a passwordless login. All you need to log in right now is the username, and then we get brought back right to our zero knowledge keypad. Again, we have a login specific informational pop-up for any users to always reference to get the behind the scenes. And so what I'm going to do here is type Jake123, and we're brought back to our zero knowledge keypad. And as previously mentioned, this is going to update every 5 seconds until 4 random points are clicked on the same image. And then that's going to, using zero knowledge principles, create and re-entangle ourselves with the SQE network to continue sending that encrypted SQE encryption. And so we have re-entangled ourselves. We're now logged in. And again, that zero knowledge keypad is just kind of the foundation for initiating that entanglement. We have further features features that are going to be able to perform that user verification and AI resistance, that we just talked about, so that we can eliminate the need for a password and be able to guarantee that concept of KYC and knowing that the user is who they say they are. And so now we're going to go back to our payments. We can see the account balance has updated itself and stored. And so you can see all the recent transactions that you've put through. This time we're going to send a payment to Virtual Charlie, $110. We'll add a description. And what we'll be able to do is, again, see that ISO compliance in effect, but also we're going to be able to compare the encryptions a little bit. And so you can see the milestones hit in real time. They're all tracked. We have a safe delivery to Virtual Charlie. And now we can compare the encryptions a little bit. And as you can see, they're completely different, but we maintained that synchronization after the entanglement, the re-entanglement through our zero knowledge keypad. And so now what we're going to do is we're going to shift over to our core use case, our other core use case of messaging. And so this is where we'll be able to take a deeper dive. And what I'm going to be doing for you guys is splitting the screen and displaying Wireshark. And what this is going to do is it's going to demonstrate a few different things. It's going to, one, be able to see the packets intercepted in real time. And we're not using TLS. I'm running this locally to be able to demonstrate to you guys that if the TLS that was in use was ever compromised and you're using the SQE encryption, that's what you're going to be seeing in the Wireshark. You're going to see that application layer security that is wrapped around your data. In this case, is going to be messages. To provide some context, what you're seeing here on the right, we have our green, which is all the packets being sent from the front end to the SQE network. The blue is the responses, so the back end responding to the front end. And I'm going to scroll through a little bit of them, as you can see from the current session here. And you'll see that every packet, because we are now entangled, or we've been entangled, everything is encrypted with our quantum secure SQE wrapper that's happening at the bit level that we're going to get into a little bit now, further now. And so we're going to send an example message here to Virtual Alice. We're going to send just a typical message of hello, Alice, and you're going to notice a few different things. First, you're going to see that the message was sent. We got the confirmation from the SQE network. You also saw that the Wireshark picked up the request and the response from sending that message to Alice. And what we're going to see is we're going to be able to compare the packets that were intercepted. And that's just to prove to you guys and demonstrate to you guys that the encryption that's happening and being stored and displayed in this sandbox is exactly what you would see over an HTTP communication, or if TLS was ever compromised, you would see the SQE encryption. So you can see that we have our non-sensitive header here at the top, and then the rest is our encrypted payload. You can see 46, 56, 50 matches, and that's exactly what you're seeing displayed, that exact encrypted payload. And so what's really interesting is to kind of tie this into, and really powerful, is to tie into what Hamid and Caitlin were talking about earlier. And that's that we sent a message as small as hello, Alice. And now what you're seeing is, at least because of how small it is, we're sending at least a kilobyte of encrypted data. And so now what we're going to be able to show is, okay, let's prove that bit level encryption. Let's prove that if you send the same character consecutively, you can see it matches it with the Wireshark. But if we send 6 of the same characters, a small message, 6 zeros, and we send it 2 messages back to back, you're going to see how fast time is evolving. The keys are different every time. And you're going to see the randomness between this encryption. And again, this is all happening at the application layer. So we just copied and pasted 6 zeros. We sent them consecutively. You can see they happened within a second apart from each other. Both messages sent. The Wireshark picked up on all the requests and responses. You can see the encryption that's happening in each of these the intercepted packets. And now let's view the encryption. And you can immediately see the difference between the two. They're completely different numbers, completely different packets, and you can see the zeros. There was no pattern between the zeros. We set 6 zeros. We received a kilobyte worth of encrypted data, and this is happening again at the bit level. This is a bit level encryption, so it's happening at the bit level. Each character is receiving its own encryption, and the other part is the security aspect of it. If any one of these characters were tampered with, the responding would immediately know that they're unentangled and that this packet isn't valid and would be unable to be decrypted. And so this ensures a huge security, huge data. And this is, again, just the tip of the iceberg when it comes to overall use cases. This can wrap not just around messages, this can scale to large packets, as Hamid had previously mentioned, in the megabytes. The encryption is very fast, and as long as the two endpoints are entangled with each other, and we can do this not just between browser and server, but this can occur between server to server communication, hardware devices, IoT, and even mobile phones as well, as long as they have that zero knowledge principle to maintain and initiate that entanglement and to create that quantum secure channel. And so now I'm going to kind of bring this back to full screen and go into our information pages a little bit. And what I really want to talk about is kind of how this SQE encryption fits in the overall kind of architecture of like secure communication, right? So the standard and what a lot of people and a lot of applications are using the TLS, right? And so that's either HTTPS or WebSocket secured. But there's obviously known attack surfaces where if that TLS is ever compromised, we know the like harvest now, decrypt later. And if what this SQE encryption allows is an application layer security, so that if the TLS is ever compromised, then essentially what you would see is the SQE encryption, keeping your data safe essentially for the long term as well. And so how do these pieces fit? We kind of talked about this a little bit with the Wireshark. What does a network observer see? Well, you can use this not only as a secondary control with TLS, but it's also because we've eliminated the need for public key cryptography, you can send this over HTTP, and you just saw the encrypted packets that were sent and intercepted by Wireshark. And then we also have our table here that kind of compares if a TLS was ever compromised or exposed, how the SQE encryption kind of responds to that, right? So again, if that TLS is ever compromised and you're using the SQE encryption, then that's what you would see. It's an added layer that you can essentially implement into your own transactions. Again, it's fast and it's at the application layer as well without having to use public keys. We also have our compliance mapper here, and this is kind of what I talked about earlier with our ISO 222 payments is SQE is acknowledging and can comply with a lot of the standards of today, the KYC, the user authentication. We have this drop downs on this page that kind of go in depth of how SQE's encryption and SQE as an ecosystem kind of comply with the standards of today. And you saw in real time the secure messaging and the ISO 222 payments as well. And so this is really important as this is kind of how we continue to look forward on our roadmap. We want to continue to improve the KYC and the keypad so that we can really verify users through their biometrics and be able to have that password login or passwordless login. Lastly, we have this portal that's powered by Netrascale that gives you the ability to create your own risk analysis report. And this is really powerful as well and allows you to sign up, register, and check that out as well. And again, for anybody that's really interested and we have a QR code that's available for you to essentially sign up, register through that QR code, and you'll be able to kind of receive a code that checks this sandbox out in real time and really get your feedback and see this again, test it out, navigate it yourself. So I appreciate everyone's time. Thank you.